For the MCQ Pop Quiz 18 related to the last week. If you have any doubt or a question, you can mention that. Question number 1, any doubt? Question 1, any doubt? Question 2. In question 2, which atom has the same number of electrons as a hydroxide ion? So how many electrons are there in oxygen? In a hydroxide, it contains oxygen, hydrogen, and additional electron is there because the charge is negative -1. So oxygen contain 8 electrons, hydrogen contain 1 electron. Plus the additional negative charge is there on the hydroxide ion. If there's a negative charge, means additional 1 electron is there. So total how many electrons are present? Total 10 electrons are present in hydroxide. So we have to check using a periodic table. Fluorine, it's having 9 electrons, like 9 proton, 9 electron. Neon is having 10. Sodium is having 11. Sodium is Sodium is having 11. And what about the magnesium? Magnesium is having 12. So that's why option B will be the right answer for this. Next is question 3. Any doubt? Question 4. Any doubt? In question 4, okay, question 4 and 5. In question 4, a student reacts 1 mole of a copper with a concentrated nitric acid to produce 1 mole of a copper 2 nitrate, 2 moles of a water, and a substance X. The substance X does not contain copper and hydrogen. What could be substance X? So if we try to write a balance equation, dimension 1 mole of a copper reacted with 1 mole, reacted with nitric acid. They did not mention how many moles of a nitric acid, but this is 1. Reacted with nitric acid, HNO3, to produce 1 mole of a copper 2 nitrate. So CuNO3 in a bracket 2 will be there. Plus 2 moles of the water. So H2O will be there. How many moles of them? 2 moles. Plus another substance we don't know. So what could be substance X? So first thing, for balancing part, because the substance does not contain hydrogen or a copper. So copper is 1, it's already balanced. What about hydrogen? 2 multiplied by 2, 4. So there's only one reagent which involve hydrogen, that is a nitric acid. So means this number should be 4. So this is a fixed number, this should be 4 here. Now, what could be substance X? If substance X was nitrogen, it can have different moles, but let's say if a substance X is nitrogen, copper is balanced, hydrogen is balanced, so nitrogen is 4 here. So if this 2 moles, then 2 nitrogen is balanced as well, if N2 was there. But what about oxygen? 4 multiplied by 3 is 12. Here 3 multiplied by 2, 6, 7, 8. So it means it cannot be nitrogen. Why it cannot be nitrogen? Because if it was a nitrogen, oxygen cannot be balanced. So that's why it cannot be nitrogen. When we check with N2O, so this is 4 here and the substance is N, if let's say a substance was N2O. Nitrogen is already balanced, hydrogen and copper are balanced. What about oxygen? 4 multiplied by 3, 12. And this is 3 multiplied by 2, 6, 7, 8. So if N2O was there, then the oxygen cannot be balanced, because if I try to balance oxygen, 3 multiplied by 2, 6 oxygen plus 2, 8, and I want to make it 12. So if I put 4 here, then the nitrogen will not be balanced. So it means this substance cannot be N2O. What if the substance is NO? So this is 4 already. Why it is 4? Because hydrogen balance. So nitrogen are 4. We want to make 4 nitrogen, 2 here. So this should be 2 here because nitrogen will be balanced. And what about oxygen? 4 multiplied by 3, 12. 3 multiplied by 2, 6. 7, 8, 9, 10. So that is making 10. So means this will not balance the oxygen again if nitrogen is balanced. And the last one, when we check the option NO2, and this is 4. So nitrogen should be 4. This is 2 nitrogen. We put 2. Nitrogen is balanced. What about oxygen? 4 multiplied by 3, 12. So 3 multiplied by 2, 6. 7, 8. And 8 plus 4 will make 12. So when NO2 is a product, nitrogen dioxide is a product, then the equation will be balanced as well. That's why D should be the right answer for this one. Is it clear? The next one is related to in which structure are the 3 atoms together in a straight line. So you can just identify the bond angles. As you can see, a carbon is there, and it's forming a single bond. Whenever a carbon is forming a single bond, what kind of bond? Like it will be a tetrahedral structure with a bond angle of 109.5. To be in a straight line, the bond angle should be 180. One of the bond angles should be 180. So this cannot be in a polyethene as a carbon will form. We'll have the structure like this, the polyethene. This is one unit. Then there will be another unit of the polyethene. So the carbon, as it is forming single bond, so the bond angle will be 109.5. And when bond angle is 109.5, to be in a straight line, the bond angle should be 180 degrees. So this cannot be an answer. When we check propane, same case for a propane. Prop means 3 carbon and ane means a single bond is there between them and remaining hydrogens are attached. So each carbon is having a single bond. So whenever carbon is having a single bond, the bond angle will be 109.5. So none of the angle will be 180. Silicon, tetrachloride silicon belongs to group 4. So when it form a bond with 4 chlorine, 4 bond pairs and there is no lone pair. So what will the bond angle? The bond angle will be 109.5 degrees. But sulfur hexafluoride. So what will the structure of a sulfur hexafluoride? Fluorine will be there. So one of the bond angle will be 180 because this is 90. So when we take this total angle, if you take this total angle, it will be 180. If you take this total angle, it will be 180. If you take this total angle, that will be 180. If you take this angle, that will also be 180. So to have a bond angle of 180, it means they're attached in a straight line. That's why D will be the right answer for this. Is it clear? Question 6. Question 6 or 7, any doubt? Question 7. In question 6, which statement about aluminium chloride is correct? What is the statement of aluminium chloride? Remember, in aluminium chloride, aluminium having a 3 covalent bond with chlorine, and it is also forming a dative bond. It's also forming a dative bond with the chlorine of another molecule because chlorine is having a lone pair, so there's a dative bond or coordinate covalent bond also, it's there in question 6. So when we check the statements, the question is which statement about the aluminium chloride is correct? Aluminium chloride has much higher melting point than magnesium chloride due to a small size of aluminium ion. The melting or the boiling point depends on the intermolecular forces rather than the size of the ions. Like we relate the size, but the main thing, whenever we explain the structure, how we explain the structure in terms of the attractive forces between the molecules and in terms of the intermolecular force. Anhydrous aluminium chloride react vigorous with water to form a solution with a pH greater than 7. So when we check about the solubility of the chloride, you have to remember this. This table is about the chlorides of, like example, if you dissolve sodium and magnesium are ionic, but Al2 Cl6, which is a simple molecular in a gaseous state, but ionic in a solid state, and there's a dative bond between them. And when we hydrolyze, so what it form? It form a pH solution with a pH approximately 2, means acidic solution. But as an option, what is written there? What is written there that it is forming a greater than, so that's why this is not correct. Each Al2Cl6 found in aluminum chloride vapor contain 2 coordinate bonds. That is how the structure of aluminum chloride appear. When you have Al2Cl6, there are 2 dative bonds are there or coordinate covalent bonds are there. And bonding between aluminum chloride is strongly ionic due to a large difference in the electronegativity. It's not the strongly ionic, it's actually a covalent is there. But like aluminum chloride, what will happen? If you see the structure, the periodic structures, so when it is in a solid state, it is complete, like AlCl3 is there. This is how it's shown. But what actually happen is aluminum and chlorine are sharing electron rather than transferring those electrons. So when you have Al2Cl6, the molecule found contain the 2 coordinate bonds. Is it clear? In question 7, black powder is a mixture of a potassium nitrate, carbon, and a sulfur. The mixture react as shown. A seal tube contain a black powder, has a volume of 100, like there is a tube which contain a black powder, and that black powder is a mixture of potassium nitrate, carbon, and a sulfur. When this black powder react, it will produce a gas, it will produce a carbon dioxide, carbon monoxide, and a nitrogen gas, and the solid is also produced. When the gas is produced, the gas will occupy because the volume of a gas is always same as the volume of a container. So if the container was having a volume of a 10 cm cube, the gas which is produced is also having a volume of 10 cm cube. All like the total volume of the gases, which include carbon dioxide, carbon monoxide, and a nitrogen, they all will have the total volume of 10 cm cube. We need the volume of a K2CO3 and are produced being ignored. Like if they're produced but we ignore their volume, like it does not contribute to taking a lot of space. How many moles of KNO3 are contained in a seal tube? So how many moles are there in a sealed tube? First, we know the temperature of the tube and we know the pressure of the tube. We did not ignore carbon, sulfur, and potassium nitrate. The black, what we have in the beginning, we have a black powder. This black powder is actually potassium nitrate, carbon, and sulfur. When this black powder reacted with, it produced the gases. What are the gases it produced? Like it's producing carbon dioxide, carbon monoxide, and nitrogen. These are the gases which are produced. So the gases which are produced, the product will take up the space, and how much space the product will take, the gases actually, they will take the same as the space of the container. If the container was 10 cm cube container, then the whole space occupied will be 10 cm cube. If a container was 50 cm cube, then the gases will occupy 50 cm cube. So that 10 cm cube is actually the volume of a container, but as the gas is released, all the gases will, the total volume of the gas which is produced is equals to 10 cm cube. And the solid which is produced when they react, it also produces a solid potassium sulfate and a potassium carbonate. So the solid which is produced, we ignore the volume. Like in the question they mentioned, we did not consider that it contribute to any volume. It will occupy, but we ignore that. So we need how many moles of potassium nitrate are there in a sealed tube. To know the number of the moles of potassium nitrate in a sealed tube, first we'll find the moles of the gas, the total moles of the gas. So how to work out the total moles of the gas? We use a formula PV is equals to nRT, where P is the pressure of the container or the gas, which is just 2 into 10 to the power 6. V is a volume, but the volume is in cm cube. So what we have to do, we have to convert into dm cube, into meter cube, I mean. So if a centimeter to meter, what we do? We divide it by 100. But centimeter cube to meter cube, we divide it by 100 cube, or we can say 1 million. So 10 divided by 1 million, it will be 1 into 10 to the power minus 5. N is a total number of the moles of the gases, which include carbon dioxide, carbon monoxide, and nitrogen. R is the general gas constant, 8.31, and T is the temperature, should be in Kelvin, which is already in Kelvin. So we will find the value of N. This whole will go there in division. So 2 exponent 6 times 1 exponent 5 divided by 8.31 times 2500. That will be the number of the moles. How many moles we get? 9.6 exponent negative 3. Okay. So this will give us the moles of the gases which are produced. So 9.6 into 10 to the power minus 4. 3 into 10 to the power negative 4 is there. These are the total moles of the gas which are produced. Now, what is the ratio between the gas and the potassium nitrate? The total moles of the gas, 3 here, and 2. So if there are the potassium nitrate and the total moles of the gases, 8 moles of the gases and 4 moles of potassium nitrate. Like that's a ratio of the moles, 4:8. So if we have 9.6 into 10 to the power negative 4 moles of the gas, how many moles of potassium nitrate will be there? X. Just cross multiply. So it will be half of it because the ratio is 1:2. So in that case, A will be the right answer. So this is 10 into 10 to the power minus 6 times 2 into 10 to the power. So this is simply, when you simplify this, 10 into 10 to the power 6 times 10 into 10 to the power minus 6. So these two will cancel out. So this will become 20. So 20 divided by 8.31 times 2500. So that will be 9.6 exponent negative 4 will be there. And then the ratio, using a ratio between the gas and the potassium nitrate, which is 1:2. So you will know the moles of potassium nitrate. That's how we worked out the moles of the potassium nitrate. So first, working out the moles of the gas, and from moles of the gas, we worked out the moles of potassium nitrate. Question 8, any doubt? Which pair is in the boiling point? A first compound is higher than the second compound. The boiling point depends on the intermolecular force. The hydrogen bond, if you compare a hydrogen bond, is the strongest type of intermolecular force compared to dipole-dipole or a dipole-induced dipole. Dipole, the induced dipole force is always there because as we have a molecules, they all have dipole-induced dipole, and the dipole-induced dipole force increases as a number of electron increases, where dipole-dipole force increases as a difference of electronegativity. Dipole-dipole force increase as a difference of electronegativity increase. And the hydrogen bond, when a hydrogen is bonded to a most electronegative element, then it will have hydrogen bond such as fluorine, nitrogen, or oxygen. So this will, OH is there, so it will have a hydrogen bond. This does not have a hydrogen bond, so A will have a, like the first element, first compound will have a higher boiling point than second. What about this one? This is an ester, no hydrogen bond. This is a carboxylic acid, which is C double bonded with OH. So this will have a hydrogen bond. So this will have high. Actually, A is the right answer, but why not B, C, or D? So when you compare, this is ether, and here we have OH is attached. So this will have a hydrogen bond. So this will have a high boiling point. Here it is an aldehyde. And in a carboxylic acid, the hydrogen bond is the strongest type of intermolecular force. So that's why it will have the highest. So second compound is having a higher boiling point than the first one. But the first example, the first compound is having a higher boiling point than the second one. This one is an ester. When we wrote here for B, it is an ester. And this is ether. Ether means like oxy linkage is there. This is ether. This is ester. Ester, when C double bonded with O and O is there, that is ester. This is methyl ethanoate. So we just have to check which is having a hydrogen bond. Question 9, any doubts? Question 9. In question 9, the unit of enthalpy change for the first equation is kilojoule per mole. The unit of enthalpy change for the second equation will also be kilojoule per mole. The unit of enthalpy change does not depend on the number of the moles. Like example, it's just a factor has changed, but the unit never changes. This is a unit. Unit does not change. Like example, if I say an object covered 30 meters in 2 seconds, what is the unit? Like what is the speed? You will say 15 meters per second. Another object covered 60 meters in 4 seconds or 10 seconds. What is the speed? 6 meters per second. But the unit does not change, because if the quantity is not changing, how the unit will change? So if the quantity is enthalpy change, so the unit of enthalpy change is irrespective of the equation. Even if I write another equation, I write carbon plus oxygen, give carbon dioxide. What is the unit of enthalpy change? The same answer, A. Because the unit of enthalpy change does not depend on the type of a reactant or a type of a product. It's the quantity. So unit of the quantity does not change with the equation. Question 10, any doubt? No doubt. Question 10. Question 11. Question 12. Question 13. What is the name of this organic compound with the structure shown? In question 13, the rule is that we always select the longest carbon chain, and after selecting a longest carbon chain, numbering should start from a nearest branch or a functional group. So when we select the longest carbon chain, 1, 2, 3, 4, this is one possibility, or this is another possibility. Both ways, it's fine. Like it's maximum 4 are there. So this is the branch, like this is a functional group attached. Now, if I count from here, 1, 2, 3, 4, the methyl group branch is coming at 2, and the functional group is coming at 3. But if I count from here, the left hand side, so the functional group is coming at 3 and the branch is coming at 4, the carbon branch. So what we give a priority, we give a priority to a functional group rather than when you have a compound and you get the same number for a functional group and for the branch of a carbon, then what you give a priority, you will give a priority to the functional group. So if I count in this way, like the previous one, then this is 1, 2, 3, 4. Second position, carbon branch. Third position, functional group. But if I count from here, 1, 2, 3, 4. Second position, functional group. Third position, I have a carbon branch. So what I will give a priority, will give a priority to a functional group. The functional group, an element or atom or group of atoms which can affect the chemical properties of the molecule, we call that as a functional group. So chlorine, we give a priority to the chlorine. That's why we are counting from the left-hand side. So second position, we have a chlorine, and third position, we have a methyl. So it is 2 chloro, 3 methyl, and 4 carbon atoms are there. So it will be butane. That's why C will be the right answer. But because of 4 carbon, and N they have a single bond. Question 14, any doubt? In question 14, methane is considered a better fossil fuel than a coal because methane is not a greenhouse. No, it's not the case. Methane is a greenhouse gas. But why we prefer a methane over a coal is mainly obtained from renewable resource. That is also wrong. It has no effect on the ozone. Methane, like they have these effects on the ozone layer, but mainly because it produces less carbon dioxide per kilowatt hour. Like when we burn methane, in terms of the 1 kilowatt hour of energy generated, it produces less carbon dioxide, which leads to a less emission of a carbon dioxide or a global warming. That's why we prefer methane over a coal. Methane is can be obtained, like example, from the waste of the cattle, as well as methane is there, which is present in a crude oil, the fraction in the crude oils, which can be cracked to produce methane. Methane is not coming from the, no, not all methane is coming from the crop. How many pi bonds, how many sigma bonds are there in this organic compound? Question 15, any doubt? Question 16, no doubt. Butene react with acidified potassium manganate at room temperature. So at room temperature, it will form a diol. So butene is there. We have like, this will have three hydrogens. This will have one hydrogen. This will have one hydrogen. This will have three hydrogens. When it will form a diol at room temperature, it has a tendency to form a diol. So the double bond, when we add, the double bond will break. The OH will be attached here, another OH will be attached here. So it is 2, 3, like because when we count 1, 2, 3, 4, 2, 3, butane, 2, 3 diol. But if it was a hot concentrated, but what if it was a hot concentrated potassium manganate 7? Then this double bond will break and the oxygen will be attached, the oxidation happen, and it will turn into a ethanol. As a double bond will break, oxygen will be attached if it was a hot concentrated. So this will be the product. So this is ethanol and ethanol will be the product. But at room temperature with potassium manganate 7, it does not produce ethanol. It does not break down, like oxidation does not happen. It it is actually, it will form, oxidation happen, but a diol is formed rather than the breakdown. So whenever, yeah, it's a 4 carbon, but when it break down with acidified potassium manganate concentrated,